Hello everyone and welcome to today's podcast AI Simplified. I am Anjali Mohite, a student of Artificial Intelligence and Data Science, and in this podcast we are going to explore fascinating concept in AI, unifications and its implementation algorithms. If you are someone who's ever wondered how computers make logical connections or reasons like human, then this episode is for you. Unification is one of the core processes that allows machines to perform logical reasoning, pattern matching, and even understand natural language. So, let's begin our journey into the logic filled world of unification. Then, contents. First is introduction. Second is objective. Third is conditions. Then types of unification, applications of unification, challenges, benefits, implementation algorithms, advantages and disadvantages, outcomes, and conclusion. Let's start introduction. What is unification? Unification is a fundamental concept in artificial intelligence, especially in fields like logic programming and automated theorem proving. In simple words, unification is the process of making two logical expressions identical by applying substitutions. Think of it trying to find what values or variables will make two different statements mean the same thing. For example, let's say we have two expressions f of xy and f of b. If we substitute x is equal to a and y is equal to b, then both expressions become identical. This substitution is called a unifier, and among all possible unifiers, the one that is most general, meaning the uses the least restrictions, is known as the most general unifier or MGU. Unification is a key step in system like Prolog, where it helps the computer match facts and rules to solve logical queries automatically. Objectives of unification. First is to understand how logical statements can be compared and matched. Second, to find substitutions that make two statements identical. Third is to enable automated reasoning, pattern recognition, and symbolic processing. Fourth one, to apply these concepts in practical systems like Prolog, NLP process, and knowledge-based systems. In other words, unification helps bridge the gap between symbolic knowledge and intelligent behavior. Then, conditions of unification. Now, unification doesn't work in all cases. Certain conditions must be met. Two expressions can be unified only if first they have the same structure. For example, f of x comma y and f of a comma b. Second, their function symbol match. F of x can't unify with g of x. Third is the constant in both expressions must match exactly. A is equal to A but not A is equal to B. Fourth one, variable can be replaced by terms but not the other way around. If all these conditions are satisfied, unification succeeds and the algorithm returns the most general unifier. Then types of unification. First is syntactic unification, second semantic unification, third one first order unification, and fourth is higher order unification. First is syntactic unification. This is simple type. It focuses only on structure, not meaning. In syntactic unification, we only check whether two expressions look the same after substitution. For example, f of x comma y is equal to f of a comma b unifies at x of a and y or b. G of x is equal to f of y cannot unify because the function symbols g and f are different. It's like comparing two sentences letter by letter without caring about what they mean. Real world analogy is imagine two files with different names but the same content. Syntactic unification would rename them so they match exactly. Second is semantic unification. Now, semantic unification goes beyond syntax. It looks at meaning. Even if two expressions look different, they mean the same thing. Semantic unification will identify that. Example: buy x of y, purchase x of y, unified semantically. Father x of y is equal to parents x of y. Male x, unified semantically. It's like realizing that car and automobile refer to the same concept. Semantic unification is especially useful in natural language processing and knowledge representation, where meaning matters more than structure. Third is first order unification. This type works with first order logic. It allows variables, constant, and functions, but not functions of functions. It's the most commonly used type in AI system, especially in prologue and theorem proving. Fourth one is high order unification. This is more complex. It deals with functions or variables that can represent other functions. It's powerful but computationally expensive and is mainly used in advanced theorem proving or symbolic mathematics. Then applications of unification. Unification plays a key role in many areas of AI. First application is logic programming Prolog. It's the heart of how Prolog solves queries by matching pattern and substituting variables. Second is automated theorem proving, used to derive conclusions by matching and resolving logical clauses. Third one is natural language processing, helps phrase, sentence and match grammatical structures. Fourth one is knowledge representation, enables AI systems to apply logical rules by identify relationship between facts. Fifth one, expert system, helps in reasoning where conditions and facts need to be matched dynamically. Then implementation algorithm. Let's benefits. Efficient reasoning, enable automated reasoning in AI and logic-based systems, simplifies problem solving, reduces complex logical problems to simple variable substitution. Third one is foundation for logic programming, forms the core of programming language like Prolog. Fourth one is supports automation, help in automated theorem proving and reasoning systems. Fifth one is data integrity, ensures that knowledge base used in unification and accuracy avoid false reasoning. Then implementation algorithm. Let's understand how unification is actually implemented. Here's general algorithm process. First one is initialization. Starts with the initial expressions to be unified. Second is expansion. Break complex expressions into simpler parts. Compare their subterms. Third one is evaluation. For each pair, check if they can be made identical. If function symbols don't match, unification fails. Fourth one is substitution. Create a substitution list for variables. Fifth one is selection. Choose which variable to substitute next based on the strategy, like depth first search or breadth first search. Sixth one is goal checking. Check if all parts are unified. If yes, return the most generally unified. And last is termination. Stop once a solution or failure is reached. Advantages and disadvantages. Advantages: enables efficient logical inference, flexible and reusable across AI applications, works in various fields, NLP compilers, databases, expert systems, ensure consistency in reasoning. Then disadvantages. Computation disadvantages. Computationally expensive, especially in large AI systems. The occur check process can slow down execution. Third is limited capability for high order logic, can be memory extensive for complex reasoning tasks. Then questions. Outcomes of the unification concepts and implementation algorithm is by understanding unification we gain the ability to represent the manipulate logical expressions, understand how substitutions work in reasoning systems. Third one is differentiate between synthetic, semantic, first order and higher order unification. Fourth one apply these ideas in logical programming, NLP and automated theorem proving. Ultimately, unification forms the foundation of how symbolic AI systems reason logically and make intelligent decisions. So, conclusion is to wrap up, unification is much more than a mathematical process. It's the language of reasoning in AI. By finding the right substitutions, AI systems can match patterns, prove theorems, and even interrupt human language meaningfully. Although it has its computational challenges, unification remains one of the core pillars of symbolic AI and continues to influence research in logic programming, theorem proving, and natural language understanding. Thank you.